Okay, everybody. So let's start the webinar. Thank you very much first of all that you are available for this webinar. We are going to have today a 30-minute session for discussing about MINT protocol and mobility project. MINT protocol is the basis of R5000 platform and allows us to address the mobility project in a very efficient manner. The agenda for today is to provide the particularities of the MINT protocol, also to discuss about the mobility applications, the common recommendations, some highlights of our solution which address the mobility, and also the case study at the end. So first of all, MINT stands for Mesh Interconnection Network Technology. The proprietary protocol of Infinet Wireless, it operates between layer 2 and layer 3 of Burcea, and this is the transport protocol for R5000 family of Infinet Wireless products, and it ensures a fast and optimized packet transfer in the networks based on arbitrary connections. Initially, it was thought to address all the issues of the mesh networks. Of course, it involves a predictive model, which is very useful for the switching and routing engines. The basic elements of MINT, MINT areas or MINT interfaces or MINT nodes, MINT paths or MINT switch groups. So first of all, the default MINT area is defined, the border area between the RF interfaces. Actually, this area can be extended using the Ethernet ports. We have the possibility to create the PRF logical interfaces on the Ethernet physical interfaces, and in this case we can enlarge the MINT area, and of course many paths will be available for packets to reach from one node to another node. Like in the picture, in this slide, we have at least two paths from MINT node number 2 to MINT node number 5 in this topology presented. So we have very clear definition of a MINT area. We have a very clear definition of MINT interfaces. These are RF or PRF interfaces. MINT node is actually any kind of Infinet Wireless unit from R5000 family, and MINT paths are any kind of connection, the possible connection. It is not mandatory active connections. They can be possible connections, and in the future those possible connections can be active. The switch group is a new entity which we can see it as a virtual switch within a virtual Ethernet segment, which is a MINT area. We can have a correlation between a real Ethernet segment and the virtual Ethernet segment, which is a MINT area, in which we have MINT switch group, which is a virtual switch. Being a switch, it has ports, virtual ports or physical ports. In a MINT area, as we discussed before, we have MINT interfaces which are RF or PRF, and in a switch group we can have physical interfaces like Ethernet interfaces or RF interfaces. Now, which is the criteria for moving the packets from one node to another node? Actually, first of all, the MINT nodes in a MINT network, they discover each other in the background, and all this process is done automatically. Once a new node is available in a MINT network, it will understand, it will learn its neighbors, and also it will send the information about itself to its neighbors. So this is the first step, and then the MINT protocol calculates the MINT costs. MINT costs are like OSPF costs in the OSPF routing protocol. The main differentiation and the main advantage here is that MINT costs are calculated based on the radio parameters, unlike the cost of OSPF. So here we have a very fast calculation of the MINT cost based on the bit rate, SNR for instance, or link load. In a wireless environment, we all know that we have changes. Wireless is a shared medium for a lot of wireless connections, so the conditions are changing in time, are not static like in a wired solution. So in this case, we need actually a mechanism that is adapted to these changes of the medium and calculate very fast the quality of the link based on specific radio parameters, and not only. Of course, link quality assessment is done actually constantly in a constant manner, and here depends a lot the node type And we have three types of nodes. We have static nodes, we have mobile nodes, we have nomadic nodes. And depending on the node type, the information which is exchanged between the nodes can be from 1 second to 3 seconds. 1 second, of course, being for the mobile subscribers. And another important capability of Mint is to provide loop-free. The network path is computed for each and every frame. This is very important, that in order to have an efficient transfer of the data, and here I'm not talking about switching or routing, I'm talking about the ability of Mint to provide the framework for the switching and routing engines to transfer the data for the best quality path according to rapid changes in the wireless environment. So the same mechanism is applied for each and every frame within a stream of frame data. So things are very dynamic. Each and every frame is treated separated, and in this case we can say that Mint provides loop-free capabilities, because it cannot be that in the same time one frame to be sent on both Mint paths. Having in our mind all these statements about Mint protocol, which again is a proprietary protocol of Infinet Wireless, of course we have a lot of advantages, and here I'm presenting the most important advantages of Mint. So for instance, we use Mint in mobility projects, and we have huge advantages in the mobility projects, because nodes are mobile, so they change their position, they have each and every time new quality of the signal, they have to be connected to several base stations while moving. So in this case we need to have a fast handover, and we need the ability not to lose any packet in the packet transfer. But beside the mobility, we can benefit of the Mint advantages. In case of failover situations, we can have two or many possible links between nodes, as I said before, and Mint perform this automatically selection of the best path according to the best quality of the link. Actually, we have further load balancing, which is another important advantage. Mint offers the possibility to load in the same time a redundant path, but not the same data will be transferred on both paths, as I said before, but both paths become active in the same time for frames to be sent from one node to another node. And of course, another very important advantage is remote management performed at layer 2. Mint offers possibility to send and execute any CLI commands from any node to another node in any remote unit. If for these situations, the only one condition is to have an active wireless link between the nodes, and we can control the remote nodes using the Mint protocol. Mint does everything in background for us to be able to manage those remote nodes. And of course, the only one condition is to have a link active between the nodes. Now, in the second part of this webinar, after discussing about Mint in general, which are the Mint basic elements, which are the advantages of Mint, in the second part we are going to present how Infinet Wireless devices deliver mobile broadband wireless. This is very important because we act in wireless broadband area. We prove and promote the fact that also we can sustain wireless broadband in case of mobility project. In general, if we think about mobility projects, we can divide them into two main parts. The first part is for moving vehicles on the land, regardless the fact that these vehicles are trains or police cars or, I don't know, rescue cars or any other mining vehicles. And also we have over the water. These situations can be treated a bit different. Of course, there are many reasons to separate these two kind of major area of application of mobile applications. Actually, the main purpose is to provide a permanent communication with the moving vehicles and to provide broadband wireless connectivity with the moving objects, regardless of the fact that they are ferries or trains or mine vehicles. The main purpose is to provide constant and non-interruptive connectivity to all these mobile devices. And of course, from one project to another, from one application to another, there are different purposes. Other type of applications are in oil and gas industry, for instance, and as I said at the beginning, for the rescue and patrol cars. A mobile network can be deployed in such a way in order to achieve the initial requirements of the traffic for this kind of projects. For instance, for the rescue and patrol cars, maybe we need to provide the broadband connectivity to transmit real-time streaming from the video surveillance cameras, which can be installed on those type of cars. Now, having presented the applications, the next goal of the webinar is the solution that Infinet Wireless has in order to address all this kind of mobile application. But before that, we need to introduce the InfiMUX switch, which is not in general availability right now, but has been so far used for specific mobility projects. But it is very important to discuss about it because it has a huge role in the mobility project. First of all, this is a 6 gigabit Ethernet port with dual-core Intel Atom processor, and the most important is that they have one flex of the operating system, of course with MINT protocol available. This is the major advantage of this switch, because they run MINT protocol and we can benefit of all the advantages that we discussed at the beginning about MINT. Regarding the solution highlights of Infinet Wireless for the mobility, actually my goal for this webinar is just to provide the general recommendations. Of course, each and every project, mobility project, has its own particularities, and we provide huge flexibility in choosing the right configuration for addressing the specific project. So in these slides, I'm just presenting the general recommendations. Of course, they are not the same for all type of mobility project. Few things must be taken into account for any kind of project, a mobility project. First of all, the CPEs must be configured and provisioned, of course, with radio profile for each base station in the wireless network, because in a mobility network we have many base stations in different locations which cover different areas, and the moving CPEs are of course moving in the coverage area in order to send and receive traffic from this base station. So first is important to make sure that the mobile CPEs can be connected at any time. In case they are in a coverage area of a base station, they have provisioned the radio parameters to be connected with. Multi-base station option must be enabled, and mobile type of the CPE, of course, must be set on the CPE. Why we need mobile type? Because the time to exchange the information about the cost, the MINT costs, and other parameters, in this case, will be done at each and every second. In case of a fixed CPE, these information are exchanged at each and every 3 seconds. Multi-base station is important to be activated because in this case the CPE will cut the communication and the connection with the former base station at a threshold which is different from the situation where the multi-base station is not activated. In that situation where multi-base station is not activated, the CPE will try to reconnect to the base station for much longer time, and of course in case of multi-base station option, in case this threshold is reached, then the CPE automatically is searching for the next base station, and of course we have a faster handover, and chances to have traffic interruption are very low. From the point of view of InfiMUX, and here in this schema is just an example, it's just a recommendation how the InfiMUX can help to reduce to zero the traffic downtime, of course to have a faster handover and to avoid loops. In this case, we don't need at all the spanning tree protocol to be used, because as we said at the beginning, the MINT protocol does this for us and has loop-free capabilities. In case of InfiMUX, in such a network, in such a deployment, it will know in each moment which are the possible links and also the active links. And Mint calculates the cost between each and every link. So it can influence the switching engine to switch packets from one link or another. Of course, we can have here in this scenario different possibilities. Actually, 4 possibilities. We can have CPE1 and CPE2 to be connected in the same time to one base station, or CPE1 to be connected to base station 1 and CPE2 to be connected to the base station 2 in the same time. But in order to avoid such connections, we can perform configurations in the CPEs. We can set different bit rates for each of the CPEs in order to make sure that they don't stay connected in the same time to the base stations. Why we need to use 2 CPEs, for instance, for a mobile vehicle? The answer is it's very easy. In order to have higher probabilities to reach one of the base stations, because in the mobility project we can have high altitudes, for instance, for some base stations, low altitudes for some from other base stations, and also for the mobile CPEs we can have different heights along the way the CPE is moving. So we just need to make sure, according to a correct radio planning and deployment of such mobility project, that we have defined the coverage area in such a way to make sure that we don't have signal loss in none of the zones of this area. And now we have to discuss about the antennas, because apart from the Mint, apart from the network configurations in the unit, without a proper deployment of the network, without a proper radio planning and antennas, we actually don't benefit of the advantages of Mint, as we discussed at the beginning. So in order to benefit of all these advantages, we need to make sure that the mobile CPEs are into a coverage area and have all the time connectivity to the base stations. So we can have the following options. First of all, for a lot of applications, it is recommended to use omnidirectional antennas for the CPEs. Regardless if we use one CPE connected with a mobile vehicle, or 2 or 4 CPEs, for a lot of application, advised to use omni antennas. Here it's very important one aspect, because of course both antenna will work on the same frequency. To benefit on the space diversity, or to make use of the space diversity and to connect those 2 omnidirectional antennas in a distance one from the other one equal with half of the wavelength. This is very important. And of course the base station can have dual polarized antenna, sector antenna, but to use of course MISO mode. In this case the omnidirectional antennas, they transfer in the same time the same data. So in this case we cannot actually benefit of the MIMO, because the highest goal is to provide the coverage. So in this case we have to use multiple input and single output for the unit. Another type of deployment is to use, for instance, in vessels, in the situation or projects where we need to have a coverage in areas over the water, for instance, where distances are even up to 50 or more kilometers. I mean, the distance between the base station and the mobile vessel over the water. Then in this case the situation is completely different from the situations in on the land mobility project. And it is advised for this kind of applications. We have learned that for CPEs, each of them connected to sector antenna, it can be 90 degrees or 120 degrees. In case of over-the-water project for vessels, we are limited in locations where the base station can be deployed. So it's not like in a land mobility project where we can place how many base stations we need. In case we have higher flexibility for this kind of deployments, In the projects for vessels, for moving vessels, we have a limitation regarding the locations for the base station, and due to the fact that the distances become much higher. So in this case, we can use this solution for, again, InfiMUX to control the four CPEs, which in this case will work as simply bridges, radio bridges, and they don't have any decision to take in case of transport of the data. They just make sure they receive the signal from the base station. And in this case, the base station, vice versa with the situation for on the land mobility project, the base station can have directional dual polarization antenna. What I wanted to show you in this webinar is that we have flexibility. We don't limit the deployments. We have full flexibility, and depending on the mobility project, you can use any kind of antenna that allows you to receive the best performance in case of your deployment. The last part of this webinar today is to discuss about a case study. This one is actually not the most relevant case studies from the ones that we have, but I choose this one because I also want to provide some figures about the speed of the moving vehicles that have the CPEs installed on them. So in this trial, we have a base station which is mounted on a bridge in a highway. The name of the highway is R120 between Smolensk and Bryansk cities in Russia. The base station, one base station actually is within the integrated antenna 16 dBi is mounted on a bridge 10 meters above the ground. And of course, the antenna was installed in such a way to provide the coverage along the highway. And then we have a mobile vehicle, a car which has two omnidirectional antennas connected to one CPE. And of course, the height of these antennas are no more than 2 meters above the road. Due to the particularities of the terrain in that area, in this specific highway, the base station cannot have a coverage more than 3 kilometers. So we had to use intermediate point, which can take the traffic from the moving car. The intermediate point is installed at 3 kilometers away from the base station, where the signal is decreasing to 4 dB. This is the SNR this is the SNR threshold that was encountered in case the handover between the base station and the intermediate station. It was measured that in this case the handover was performed in less than 1 second and no traffic was interrupted. And as you saw in the previous slide, the car was moving with a speed of 120 kilometers per hour. Actually, as I said at the beginning, I choose this trial in order to point out that we are not necessarily limited by the speed of the vehicle. So in this case, the car moved with 120 kilometers per hour. In this slide, although the figures are in Russian, you can easily understand that the numbers are expressed in megabits per second. You can see the intermediate point on this map, so it's easy to see regardless the language. And of course, the throughput values are displayed at different points on the highway, regardless the fact that the moving CPE is in one moment of time connected to the base station or to the intermediate station. So actually the maximum throughput was in this case achieved at 44 megabits per second. Actually, I don't have all the configuration for the unit, so I don't have for this specific trial the information about the bandwidth use, the bit rate and so on, but the maximum throughput was achieved was 44 megabits per second, and the lowest figure was 7 megabits per second. The message is that MINT protocol is allowing the fast handover, no traffic interruptions, and provides flexibility in choosing the proper deployment for the mobility project. I would like to thank you for being part of this webinar. Thank you very much.